I hope you are staying safe at home. Alright, in our last discussion, we had focused on the use of Pearson product moment correlation method in testing hypothesis. Okay? However, today is a continuation of that discussion. We are going to focus on the use of Spearman rank order correlation method in testing hypothesis. Alright, the Spearman rank order correlation talk about use of ranks. And the formula is given as P. This looks like P. Sometimes it is written as raw. And so it can either be raw or P is equal to 1 minus 6 summation D square all over N into N square minus 1. That's the formula for Spearman rank order correlation method. And then there are some conditions under which this method can be used. Number one is that measurement should be either at nominal or ordinal level. Of course, you remember that when we talk about Pearson product moment correlation method, we did mention that measurement should be at interval correlation scale. But for Spearman, measurement should be at nominal or ordinal level. Number two, the data should be discrete, meaning that there should be no fraction. And using Pearson, the data should be continuous, but in Spearman, the data should be discrete, meaning that the data should appear as whole number. There should not be any fraction. And then, number three, the sample size should be small. Number four, Spearman assumes that the scores are repeated or related or connected with each other. That is repeated measurement. Number five, it is used when the relationship between the two variables is curvilinear. Remember that for you to use Pearson, it must be a linear relationship. But for Spearman, it can be curvilinear, meaning that it can be positive, can be negative, or as the case may be. Spearman rank order correlation is not parametric statistical test. You should know that Pearson is parametric, but this Spearman is non-parametric. Then number seven, there should be 2 pairs of scores. These are conditions that must be fulfilled before the Spearman can be used. Okay? Now, how do we use the Spearman rank order correlation in testing hypothesis? Number one, you must state an appropriate hypothesis. I know you are conversant to this. State an appropriate hypothesis. And then 2, state the level of significance. And then step 3, calculate the test statistics to obtain the correlation coefficient using the formula P. I said it can be raw, can be P equals to 1 minus 6 into D square all over N into N square minus 1. And then for you to do that, you must rank each of these scores. You must rank them. We are going to come to that. And then step 4, convert the correlation coefficient to t-test value using the formula. T is equal to P. Anywhere you see P, you know that it's talking about the correlation, Spearman correlation, all over square root of 1 minus P squared, P again, into square root of N minus 2. And then 5, determine the degree of freedom using the formula N minus 2. And then 6, make comparison. And 7, draw conclusion. Okay? There's an example here. The following are scores of students in mathematics and physics. In mathematics and physics. And then you have students that have those scores. Students 1, 2, 3, 4 to 14. And then their scores in mathematics. In this example, mathematics score is X, while physics score is 1. And you can see the scores here. For mathematics, you have 12. Student 1 scored 12 in mathematics and 13 in physics. Student 2 scored 9 in mathematics and 8 in physics. Student 3 scored 15 in mathematics and 17 in physics, and so forth and so on. Student 14 scored 9 in mathematics and 11 in physics. The scores are already there. And so the hypothesis now is that mathematics and physics scores does not significantly relate. Remember, that's the null hypothesis. Mathematics and physics scores of the students does not significantly relate. And then the level of significance is 0.05. Now this is serial number of students 1 to 14. This is a mass score, mathematics score of student X, and then column 3 is the physics scores of student 1. And then when you look at column 4, you'll be wondering how it come about 8. You rank the scores in the mathematics column from the highest to the least. Now, if you look at this column very well, look at the scores in this column, you will notice that 18 is the highest. And so that 18 is rank 1. That 18 is rank 1. After 18, the next score is 16. And 16 is again rank 2. After 16 is 15. Incidentally, you have 15 appearing 3 times. There is 15 here, and there is 15 here, and again there is 15 here. Remember that 18 and 16 has taken first and second position respectively. And so this 315 was to take position, the third position, the fourth, and the fifth. And because they were supposed to occupy position 3, 4, and 5, of course they are the same score, and then remember the idea of brackets. They have the same bracket. And so what you do is to add those positions and divide by 3, such that 3 plus 4 plus 5 will give you 12. Will give you 12. 3 plus 4 is 7. 7 plus 5 is 12. Divide by 3, and that is 4. That is why anywhere you see 12, in this arrow S, which shows the ranking for mathematics, because mathematics is X, the rank of X. Anywhere you see 15, what is there is 4. Look at 15 here, 4. Another 15 here, 4. Another 15 here is also 4. So don't get confused when you get to that point. Now after 15, the next one is 14. Because the 15 has taken 3rd, 4th, and 5th position, score 14 will now take 6th position. And after that, you have 13, 7th position. After that, you have 12. Incidentally, 12 occupy 2 slots. And so you also need to find out their position. 6, we are taking 6 and 7. We are taking 6 and 7. And so 12 is supposed to occupy 8 and 9 position. And then what you do is to add it together and divide by 2. 8 plus 9 will give you 17. 17 divided by 2 will give you 8.5. That is why anywhere you see 12, you also see 8.5. And then 11 will take the 10th position, while 10 take the 11th position. 9 appear also. If you look at it, you will notice that 9 is occupying 12.5 position. It appears as 9. It appears twice. It should be here. It should be here. This one should be 9. 9 here and 9 there. And so 12. And then after 9, you have 18 positions, you have 8 occupying the 14th position. What I want us to know is that these scores are ranked from the highest score to the lowest score. Now, after ranking the mathematics score, we also rank the physics score. The physics score, 18 is also the highest, followed by 17. And 17 appear twice. And so 17 is occupying second and third position. And so you have 5 over 2. And that's why anywhere it's 17, what you have there is 2.5. After ranking both mathematics and physics scores, you now subtract them. That's why you have the linear deviation or difference between rank of X and rank of Y. Rank of X and rank of Y. Remember that X stands for mathematics score, Y stands for physics score. Okay? 8.5 minus 8 will give you plus 0.5. 12.5 minus 14 will give you minus 1.5. 4 minus 2.4 will give you plus 1.5. 11 minus 11, 0. 6 minus 2, minus 2. 6 minus 8, minus 2. 10 minus 8 will give you plus 2. 4 minus 4.5 is minus 0.5. This is minus 0.5. 14 minus 13 plus will give you plus 1. 2 minus 2.5 will give you minus 0.5. 8.5 minus 11 will give you minus 2.5. 7 minus 1. 7 minus 6 will give you plus 1. 4 minus 4.5 will give you minus 0.5. 1 minus 1 will give you 0. 12.5 minus 11 will give you plus 1.5. Now you see that in this column, some of the scores are positive, some are negative, some of the scores appear in positive integer, while some appear in negative integer. And so that's why we have this D2. That is any score you have here, you square it to minimize, to eliminate these positive and negative signs. And so 0.5 squared will give you 0.25. 1.5 squared will give you 2.25. And 1.5 squared will give you 2.25. Now when you square a score, that's multiply it by itself. The positive and negative integer disappears. And then the score now is a whole number. 0 square, of course, will give you 0. 2 square 4, 2 square 4, 0.5 square, 0.25. 1 square will give you 1. 0.5 square will give you 0.25. 2.5 square will give you 6.25. 1 square will give you 1. 0.5 square will give you 0.25. And then 0 square will give 0, while 1.5 square will give you 2.5. When you add all of them, it will give you 24. So, deviation square will give you 25. Will give you 25. That's how we come about this, to give you 24. That's how we come about this 24. We don't need to add any other column. No column here is necessary apart from this last one that is reflected in the formula. Now, in that case, you apply that formula. Remember the Spearman rank order formula. Look at it, equals to 1 minus 6 into d square all over n into n square minus 1. Okay? Remember 6 times our sum of d square is 24, so you put it there. The number of scores here is 14. That's why you are seeing that 14 into 14 square minus 1. Now, 6 times 24 will give you 144. For this 14 is here. 14 squared will give you 196. Minus 1 will give you 195. And so P is equal to 1 minus. If you multiply 14 by 195, what you have is 2/7. Now 1 minus this will give you 144 divided by 2730 will give you 1 minus 0.05274772. And therefore, if you subtract this from 1, you have 0.9472527, approximately 0.95. Now, after you have, that's the correlation coefficient between these two scores, between the mathematics and physics scores. When you have done that, you then do what we call T transformation. T transformation, you want to transform this correlation coefficient to T value. And the formula is T equals to P all over square root of 1 minus P squared into square root of N minus 2. Okay? Where P is correlation coefficient and stands for number of scores. Now, that formula now, anywhere you see P, is talking about the correlation coefficient. Now, the P here is a correlation coefficient 0.95 all over square root of 1 minus 0.5 squared into 14 minus 2. And then 0.95 into 1 minus, we have squared it, we have squared 0.95. And this is what it has given, 0.8649 into 14 minus 2 will give you 12. And then T is equal to 0.95 into, if you subtract this, 1, if you subtract 0.8649 from 1, what you have is 0.1351 into square root of 12. Okay? And then, if you find the square root of 0.1351, what you have is 0.36755595. You multiply, divide it by 0.95, and then this is the square root of 12. In that case, you multiply this, by this. If you square it, 0.95 divided by 0.36 will give you 2.584644, and then you multiply it by this square root of 12. That's why you have it here, 3.464, and what you have is 8.953. Now after that, this is the T value. This is assumed to be the calculated T value. The degree of freedom, remember, is n minus 2, and our n is 14 minus 2 is 12. You now check, this is the calculated T value. You now check this 12 under the t-test table. What you are going to, under 0.05, what you have is 2.179. And since the calculated value is greater than the critical value, of course you know, we have discussed this severally in our class, that where the calculated t-value is greater than the critical t-value, the null hypothesis is rejected, while the alternate hypothesis is accepted. And so the conclusion here is that since calculated t-value 8.953 is greater than the critical t-value 2.179, the null hypothesis is rejected, the alternate hypothesis is accepted. Now, what does that mean in relation to the correlation between math and physics? It's only showing that the relationship between the mathematics course and physics course are statistically significant. And that is what this calculation is saying. And so that null hypothesis we earlier stated that mathematics and physics course does not significantly relate is what has been rejected. What is there now? What we are accepting is that mathematics and physics course significantly relate. Thank you. Stay safe. We have come to the end of this course. We are expecting an exam now. Prepare well. All that we have done in class, do well to look at it. Read up. You can send your question to my WhatsApp page. I'm going to answer it. Not only on this topic, but from where we started on inferential statistics. Do ask your question. I'm surprised that during this lockdown, none of you have asked a simple question on any area of inferential statistics. I don't know whether you are learning at home. If you are learning and understanding, that's good. Please do ask me your question where you are confused so that we can iron it out before the exam. God bless you. I send my greetings to your parents. Stay safe, and I'm praying to see you very soon. Thank you.